Very good morning, children. Nice morning to you. Hi, children. Today we are going to learn about equivalent resistance of of resistors connected in series, connected in series and in parallel. So here in series, then equivalent resistance Req is equals to R1 plus R2 plus R3. Let us take the three resistors are connected in series. So in this manner, now let us take first of all in series connection. Here take R1 resistor and R2 resistor and R3 resistor. These three resistors are connected in series and these three resistors are connected to a battery. So there is a flow of current from positive terminal of the battery to negative terminal of the battery. So there is only one way to flow of current. Now let us assume that the current passing along R1, R2 and R3 resistors is I current. So there is only one way to flow of current. That's why these three resistors are said to be in series connections. Okay, let us say that. Now the resultant resistance or equivalent resistance of this circuit Req is equals to R1 plus R2 plus R3. If three resistors are connected in series, Req is equals to R1 plus R2 plus R3. Then in parallel, if you take a parallel connections, in parallel, then let us take that. This is R1 resistor and R2 resistor and R3 resistor. That is nothing but resistance of the first resistor be R1, resistance of the second resistor be R2, resistance of the third resistor be R3. These three are connected to a point and these three are connected to a point. Then, okay, so this is point A, let us say that this is point B, and then these are connected to battery positive terminal and negative terminals. Now let us say that the current flowing from current starts I current is passing from positive terminal of the battery, but at this junction point this I current splits into I1 and I2 and I3 current. I1 current is passing along the resistor R1, I2 current is passing along the second resistor, I3 current is passing along the third resistor. But again, at its junction point, I1, here I2 and I3 at this junction point, then again I current flows out of the junction point B. Then equivalent resistance of resistors connected in parallel. Then how can we calculate? 1 by Req is equals to 1 by R1 plus 1 by R2 plus 1 by R3. So this is a equation which is connected in parallel connections. Then here, then R1, R2, R3. So here R1 into R2, sorry, R2 into R3 plus R1 into R3 plus here R1 into R2 by doing simplification. This is 1 by Req is equals to in parallel connection. Therefore, Req is equals to R1 into R2 into R3 by R1 R2 plus R2 R3 plus R3 R1. Just I have written as in an order. So this is equivalent resistance of resistors which are connected in parallel connection. When I have taken three resistors, that's why R1, R2, R3, three resistances I have taken. Now let us look at a problem based on equivalent resistance formulas. Now let us take a problem. Find out the resultant resistance of this circuit. Now let us say this is 2 ohms resistance. This is 3 ohms resistance. Sorry, this is 3 ohms, and let us take this is 2 ohms because the length is less. Okay, 3 ohms resistance and 2 ohms resistance, and which are connected in this manner. Then we have to find out the equivalent resistance of this circuit. This is positive terminal and this is negative terminal. So this is an electric circuit. Now we are going to find out the equivalent resistance of this total circuit. Okay, as you know that, let us say that this is the first resistor, and this is the second resistor, and this is a third resistor, and this is a fourth resistor. Here you see first and second resistors are in series, third and fourth resistors are in series, but these 1 and 2 resistors are parallel to third and fourth resistors. So now let us say that first of all, let us find out that resistance of first and second resistors, these two resistors, then R1 comma 2 is equals to R1 plus R2. So R1 plus R2 is nothing but 3 plus 2 is nothing but 5 ohms. Now in this manner we can find out that equivalent resistance of third and fourth resistor R3 comma 4 is equals to R3 plus R4. That is 3 plus 2. 3 ohms, here 2 ohms. 3 plus 2, 5 ohms. But we know that first and second resistors are parallel to third and fourth resistors. That's why Req of, now you see here, 1 by Req, because in parallel connection, is equals to 1 by R1 comma 2 plus 1 by R3 comma 4. Okay, so I'm rubbing out this diagram. Okay, no problem. We can do it here. 1 by R1 comma 2 means 5 plus 1 by 5 is nothing but 2 by 5. But don't forget it. This is 1 by Req is equals to. Therefore, Req is equals to 5 by 2. So here 5 by 2 is nothing but, then Req is equals to 5 by 2 ohms. That is 2.5 ohms. So the total resistance of the circuit is 2.5 ohms. Okay, children, let us enjoy my videos. Let you, and bye bye, children. We will meet with another video in the next video. Bye bye, children.